There are a number of applications where it's useful to hold expressions unevaluated, either for displaying expressions in labels or other output, or for various reasons in programs. Starting with unevaluated expressions in output, this input shows a plot with a callout label where the label specified in the input is the equation sine of pi equals 0, but instead of showing that equation, the label that appears in the plot is the value true, which happens because the equation in the input evaluates to true before the label is displayed. That evaluation can be prevented using the hold function, which displays the unevaluated equation but also includes the enclosing hold. An alternative to hold is hold form, which works like hold except that hold form doesn't appear in the display. Another tool for displaying unevaluated expressions is the inactivate function, which gives the same display as hold form, at least in this example, but inactivate works in a completely different way. To see how inactivate works, this shows inactivate applied to the equation in that input and input form of the result. As can be seen in the result from input form, inactivate works by enclosing the heads of expressions with inactive, or more specifically by enclosing heads that are symbols with inactive. Symbols are important here because evaluation rules are attached to symbols. Unlike expressions wrapped in hold or wrapped in hold form, the inactivated expression does get evaluated, but wrapping all of the symbols in inactive prevents evaluation rules from being applied. In this example, evaluation rules for the sine function are not applied, so sine of pi does not evaluate to 0, and evaluation rules for equal are not applied, so the equation does not evaluate to true. For the purpose of formatting, however, a symbol wrapped in inactive is treated like the unwrapped symbol, so the inactivated expression formats like the original expression. The inactivated expression can be activated using the activate function, which removes all of those inactive wrappers, and in this example, the resulting expression evaluates to true. The effect of activate is similar to the effect of release hold, although the mechanism is quite different. The activate function provides another useful feature, however, through an optional second argument that allows for a selective activation. For example, this input uses the second argument in activate to indicate that only the sine function should be activated, which causes sine of pi to evaluate to 0 without evaluating the enclosing equal function. The result displays as the unevaluated equation 0 equals 0, since equal is still wrapped in inactive, which prevents that equation from evaluating to true. The remaining evaluation can be done by applying activate a second time. This selective activation of an expression can be useful for showing the steps in a calculation or in any situation where it's useful to only apply evaluation rules for selected symbols. The invisibility of hold form and inactive can potentially lead to confusing results, particularly when held or inactive results are edited. For example, here is a result from hold form. If that result is edited and then evaluated, the editing outside of hold form is evaluated, but editing inside of the invisible hold form remains unevaluated. To analyze what is going on in a result like this, it can be helpful to use input form or other tools that show the structure of the expression, or if it's known that the display may include expressions wrapped in hold form, release hold can be used to simply throw away the invisible hold form. In that example, rather than using hold form, there is a different function called defer that can be used to get an unevaluated expression that can be edited and evaluated normally. The defer function returns unevaluated output, but the output returned by defer is not wrapped in an invisible hold form, so the result from defer can be edited and evaluated just like any other output. So far, all of the examples have involved preventing evaluation in the display, but there are several other common situations where it's important to control evaluation. For example, holding a pattern unevaluated can be necessary when a pattern evaluates to something other than itself. For example, the replacement rules in this input do not make any replacements because the pattern underscore underscore evaluates to underscore squared, and the pattern underscore plus underscore evaluates to 2 times underscore before the rules are applied. These evaluations can be prevented by enclosing the patterns in hold pattern, which holds the patterns unevaluated but is otherwise transparent to pattern matching. Hold pattern can also be useful when making replacements in expressions that are themselves held unevaluated. For example, the rule in this example is not applied because cosine pi over 6 evaluates to something other than itself. This problem can also be addressed using hold pattern. There are many applications where it's useful to select or analyze parts of an expression without evaluating the expression, typically when that evaluation might use a lot of time or memory or is otherwise problematic. For example, consider selecting elements from a list like this, where the pause and the abort could represent any large or time-consuming evaluations. Applying the part function and evaluating that expression directly results in a 2-second delay while pause of 2 is evaluated and then the calculation is aborted without returning the specified part. The specified part is returned if the first argument in part is enclosed in unevaluated, since unevaluated prevents the unwanted evaluations. The select function can be used to pick out all of the numeric elements in that list by selecting elements for which numeric Q returns true, but this input again gives a 2-second delay and an aborted calculation because pause and abort get evaluated when the numeric Q test is applied to those elements. A solution to this problem is shown by this input, which uses numeric Q in a pure function that holds the argument unevaluated. The pure function here has the hold all attribute to prevent the argument of the pure function from being evaluated, and the argument of numeric Q is enclosed in unevaluated, which prevents the element that is being tested from being evaluated when it is passed to the numeric Q function. That selects the numeric elements. Selecting the non-numeric elements in this example raises a different issue, since the output from part and select will normally be evaluated, and the non-numeric elements in this example really need to be held unevaluated. For example, using part to try to pick out the pause and abort elements from this list results again in a 2-second delay and an aborted calculation, since those elements are evaluated after they are returned by the part function. This issue can be addressed using a separate function called extract. Extract is similar to the part function, but extract provides an optional third argument that allows for applying a function to the selected parts before they are returned, and that third argument can be a function that holds things unevaluated. For example, this shows extract with hold as that optional third argument which returns the specified parts enclosed in hold. Another function that provides a way to apply a function to selected results is the cases function. For example, this shows cases picking out all of the even numbers in a list, and this shows cases returning those numbers wrapped in hold. In this example, the second argument in cases is a rule, and the right side of that rule gives a function to apply to each selected element. For the list containing pause and abort, this shows cases, again with a rule as the second argument, returning those elements wrapped in hold. In this example, unevaluated prevents evaluation of the list that is passed to the cases function. The pure function has the hold all attribute, so elements are not evaluated when they are tested for matching this pattern. The argument in the numeric Q function is enclosed in unevaluated to prevent evaluation, and the return values are enclosed in hold. One other function that provides a way to apply a function to returned results is toExpression, which is used for turning strings into expressions. For example, this shows toExpression used with input form as the optional second argument to specify that the string is in input form format, and hold as the optional third argument so that the returned expression is wrapped in hold. Elements can then be selected from that list in a variety of ways. For example, this moves the hold so that each element in the list is enclosed in hold. After that, elements can be selected using select, as in this example, and since those elements are already enclosed in hold, they can easily be returned without the unwanted evaluations. There are also, of course, situations where it is desirable to cause evaluation of elements that would otherwise be held unevaluated. For example, here is a plot input with an option that adds a label, but instead of entering this input all at once, it is sometimes more convenient to assemble the input from separate pieces. The plot label option, for example, could be assigned as the value of a variable. If that variable is used as an argument in plot, the evaluation fails because the plot function expects options in the form of rules or lists of rules, and although the value of that variable is a rule, the variable itself is just a symbol. The plot function holds arguments unevaluated, so the necessary evaluation doesn't happen. One solution in this example is to enclose the variable in evaluate. It is also possible to insert the value of that variable into the plot input before the plot input is evaluated. For example, here is a pure function that takes the options as an argument and inserts those options in the appropriate place in a plot input, and this applies that function to the variable that gives the plot label. The same thing can also be done using the with function. There are actually many similar situations where it is convenient to construct an input by inserting or deleting parts of a held expression. For example, one way to pick out numeric elements in the list in this string without evaluating the non-numeric elements is to start by turning the string into a list enclosed in hold. Then use the position function to find the positions of the non-numeric elements in the held list, and use map_at in the result from position to enclose the non-numeric elements in hold. After that, release hold can be used to remove the outer hold without evaluating the non-numeric elements. Now that the non-numeric elements are enclosed in hold, subsequent operations like select can be applied without the unwanted evaluations. In the Wolfram documentation, links to information on all of the functions that were covered in this section can be found in the guide page on evaluation control.